Okay, here we go. Okay, so today we're starting exponential functions. Notice what you can recognize an exponential function because the x variable is an exponent. You've never had that before, right? So we're going to do some graphs. We're going to do y equals 2 to the x, y equals 3 to the x, y equals 5 to the x, y equals 1 half to the x, y equals 1/3 to the x, y equals 1/5. Do you notice that these guys, they have something in common, right? The 5 to the x and 1 over 5 to the x. So these guys have something in common. Does anybody see what they are? What do you think? Can anyone see how this one might be related to this one? Let me show you something, okay? We have y equals 5 to the x, and we have y equals 1/5 to the x. Do you agree that this is equal to 5 to the minus x? Right? So they are, this graph is a reflection of this graph in what axis? Y-axis. Perfect. Okay. I'm going to give you the numbers just for time's sake. 2 to the negative 3 is 1 over 2 cubed, which is 8. 2 to the negative 2 is 1 over 2 squared, which is a quarter. 2 to the negative 1 is 1 half. 2 to the 0 is 1. 2 to the 1 is 2. 4, 6. 8. Yes, thank you. My bad. Let's do 3. 3 to the negative 3 is 1 over 2, 7. 3 to the negative 2 is 1 over 9. Uh-oh. That's wrong, isn't it? That should be 1 over... Yeah, that's right. Oh, my eye jumped. My eye jumped. 3 to the negative 3 is 1 over 27. Thank you. 3 to the negative 1 is 1/3. 1, 3, 9, 27. We won't be able to graph these. We'll just graph whatever the grid fits, okay? So this is 5 to the negative 3 is 1 over 125. 5 to the negative 2 is 1 over 25. 5 to the negative 1, 1 over 5. 1, 5, 2, 5, 1, 2, 5. So far so good. We're just going to get these table of values up there and we're just going to graph them. Okay, 1 half to the negative 3 is the same as 2 to the 3, which is 8. 1 half to the negative 2 is 2 to the 2, which is 4. 1 half to the negative 1 is 2. 1 half to the 0 is 1. 1 half to the 1 is 1 half. 1 quarter, 1 over 8. Okay, 1/3 to the negative 3, well that's the same as 27, right? 1/3 to the negative 2 is the same as 3 squared, which is 9. 1/3 to the negative 1 is the same as 3, that's 1. 1/3, 1 over 9, 1 over 120, 1 over 27, sorry. Here we have 1/5 to the negative 3, 1, 2, 5, 2, 5, 5, 1, 1/5, 1 over 25, and 1 over 125. Let's graph all 6 of these so you can see, get a few kind of, we'll make some generalizations of what the exponential function looks like. This is very important for next year because the inverse of the exponential function is the logarithmic function. And you'll learn that in advanced function. Okay, isn't that exciting? You have to say that more enthusiastically. Okay, let's do the y equals 2 to the x. When it's negative 1, this is a half, a quarter, 2 to the 1, 2, 2, 1, 2, 3, 4, 5, 6, 7, 8. We can even do 16 here. 9, 10, 11, 12, 13, 14, 15, 16. So there's our y equals 2 to the x. When we do transformations, we'll consider that to be like the parent function. I didn't join my dot there very well, but I think you get the idea. I'm going to do y to the 1/3. This is 1 over 27, which is going to be a little lower. 1 over 9. Uh-oh. Hold it a sec. This should be 1/3. 1 over 9. 1 over... We can't draw. It's too hard to draw that, so we won't worry about it. 0, 1, 1, 3, 2, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. And we can't fit 27 on the graph, so that's okay. We'll just kind of sketch this the best we can. There we go. So this is y equals 3 to the exponent x. And this one is y equals 2 to the x. Let's do the 5. Again, notice the graph always goes through 0, 1. So 5 to the 1 is 5. 1, 2, 3, 4, 5. 25 is not going to fit on our grid, but this will come below the red one. That's okay. Try not to touch the x-axis. It should not touch the x-axis because the x-axis is an asymptote. Okay, let's do the 1/2 to the x, 1/3 to the x, etc. So why don't we, it's a reflection over the y-axis, so let's reflect this guy over the y-axis when x is, see 1/2 x, 1/2 to the exponent x is a reflection of y equals 2 to the x, so I'll just put it in. 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. And this will be 1/2, then 1/4, then 1/8. And try hard not to cross the x-axis because that, as I said before, is an asymptote. Let's do 1 over 3. Go there. I'm doing the red one, right? So when x is -1, y is 3. When x is -2, y is 9. It should be there. Just draw it the best you can. It's a little bit hard when the points are getting so tight. This will be a little bit below the black one, right? But don't try hard not to touch the x-axis. This equals y equals 1/3 to the x. And let's do the blue one. And that's y equals 1 over 5 to the x. I labeled them a little bit squishy, but I think you can figure that out. Are we okay with that? Notice it always passes through 0, 1. The parent, right? If there's translations and reflections, it might not. And notice we have an asymptote at y equals 0, or the x-axis. So far so good. Can I explain anything better? We're good? Do you need that for a minute or two? Yeah, Michael? Because these branches here, they get closer and closer to the x-axis, or this is the y equals 0 line, but will never touch. Because no matter what you do, if you take 5 to the negative million, no, this is y equals 0 or x-axis. Along this line, y is always 0, right? Y is always. X equals 0 is here. So no matter how small your number is, it will always be positive. Good? Sorry? Y will not equal 0 unless we shift it down, then y will equal 0. Yes? Yeah, consider them the parent. Especially when you get questions on graphing using transformations, you pick off the appropriate, we call them basic functions, or the appropriate parent. Yeah, we'll do that today. Are we good for the first page? I'm just going to do 2 graphing examples just because we've just done that. And we'll do graphing using transformations and graphing using mapping. You'll be expected to know each one, okay? So don't forget to put arrows. I don't know if I did that over here. You should, right? So, can you tell me what the basic function will be here? That's our first graph, right? What's our basic function? We're going to notice the theory is the same. Before I go to that, if you apply a general transformation for y equals b to the x, notice b is positive, right? All our basic functions in this unit are in this form. There's the x is in the exponent. A has to do with your reflections, vertical compressions, and stretches. K has to do with horizontal reflections, horizontal translations, horizontal stretches and compressions. D has to do with translations left and right. C is translations up and down. Just like in the previous unit, okay? Right? So that can be your theory for this unit on your study notes, right? So let's graph number 1. Y equals 2 to the exponent x. That's our parent. So hopefully that you don't even have to think anymore when you graph this. When x is 0, y is 1. When x is 1, y is 2. When x is 2, y is 4. When x is 3, y is 8, 5, 6, 7, 8. That's as far as we go. When x is negative 1, 2 to the negative 1 is a half, 2 to the negative 2 is a quarter, and so on and so forth. Right? Our next graph is we're going to handle the a. So y equals negative 2 to the x. So that's a reflection over the x-axis. That point comes down here. That one here. There. So there, that's that one. That's number 2. And this one was number 1. And let's do number 3. So now we can move it left and down 4. 1, 2, 3. No, left 3. 1, 2, 3, 4. 1. Oh, left 3. 1, 2, 3. 1, 2, 3, 4. 1, 2, 3. 1, 2, 3, 4. And this guy, 1, 2, 3. 1, 2, 3, 4. 1, 2, 3. Oh, this one will go off the grid. We can estimate it, I guess. 1, 2, no. 1, 2, 3. 1, 2, 3, 4. 1, 2, 3. Maybe down there, sort of, right? So, draw in the asymptote. Let's do that right now. The asymptote is the y equals negative 4 line. It will never go above this negative 4 line. It'll get closer and closer and closer, but never touch.
No, I mean that. I was just getting confused with how two. I thought like these stretches. But
Yeah. No, that's your, yeah, that's not your A. Yes.
Would you get the same answer if you just plugged in the x, like whatever x value you want into the equation and solving for y?
Yes.
You get the exact same answer.
But the question will be very specific because this isn't about plugging in x and solving for y. This is about understanding the effect of each number. So on the test, we'll want to,
Okay.
right? But if I were to put in negative 1, this is negative 2 to the 2, which is negative 4. So negative 1, negative 8. 1, 2, 3, 4, 5, 6, 7, 8.
Okay.
Right? And don't forget to label. That's important. So, they're asking us for stuff here. Okay, so sketch is a series of transformations we did. Label all graphs we did. Label the asymptote we did. State the domain and range. Well, x can be anything, right? And our range, well, the range is confined by this asymptote. So it's y such that y is less than or equal to negative 4. Y is the element of real numbers. And just like in the last unit, they ask us to describe the transformations. So number 1, vertical reflection over x-axis. 2, horizontal translation, left 3. 3, vertical translation, down 4. Just like the last unit. It's just basically a review of the last unit. However, you have a new basic function. Hence, the title of the course, Functions 11. Right? Are we good at this? Can I? Yes. Sorry? Oh, yes. Thank you. Y is less than negative 4. You're right. Thank you so much. Thank you, thank you, thank you. Thank you so much for pointing that out. My mistake. Thank you. Good. Let's now do an example using mapping. We'll do this one. Do you remember every point x, y? You can handle the transformations using mapping. Right? So now we're going to graph this. We're going to graph the parent function, and then we're going to graph the final function. But let's do our table of values. Let's label our axes properly. We'll do a table of values here for the parent, and then we'll transform them. So this will be y equals 1/3 to the x. Alright, this is y equals 1/3 to the x. Then we'll do a table of our revised table of values for the transformed function. So, do you see that a equals -1, k equals +1, d equals 6? If it helps you, this is the same as d, this is the same as c. And c equals 4. So our transform function will be x divided by k, right? X divided by k is just x, and we're going to add 6, so this becomes x plus 6 and -y plus 4. Good? That I'm just using the formula here. Yes.
Isn't it -x plus 6 because it's negative?
This reflects the y value, not the x value. This is a reflection over x, so the x stays the same. It's a reflection over the x-axis, so it stays the same. Okay. When x is negative, I guess we'll start at, well, -3, we're going to get 27. So, right, 1/3 to the -3 is 20. That's too big. So let's do -2. 1/3 to the -2 is 9. 1/3 to the -1 is 3. 1/3 to the 0 is 1. 1/3 to the 1 is 1/3. 1/3 to the 2 is 1/9. And these points are getting so small it's too hard to draw. So let's plug -2 here, we get 4. -1 here, we get 5. 0, we get 6. 1, we get 7. 2, we get 8. -9 plus 4 is -5. -3 plus 4, -9, no, yeah, -9 plus 4 is -5. -3 plus 4 is 1. -1 plus 4, something's wrong, yeah, is 3, that's good. 1/3 plus 4 is, -1/3 plus 4 is approximately 3.6666, which is about 3.7. It's basically 4 minus 1/3, right? 4 minus the 9th is approximately 3.9. We'll just have to estimate it a bit, okay? That's just because it's getting close to the asymptote, which is y equals 4, so it's doing funny stuff with us.
Wait, what's the y coordinate when x is 5?
1?
Was minus 1.
Well, minus 5, oh yeah, I guess it's, well, no, we're plugging in here. Are we doing this one?
Yeah, that one.
When x is negative 3, like 3,
Yeah, negative 3.
plus 1 is positive. Any other questions? So let's graph the parent function and the transform function. I'm going to do it in red because now I'm realizing negative 2 is 9. 1, 2, that this is going to interfere a bit. 1, 2, 3, 4, 5, 6, 7, 8, 9. Negative 1 is 3. 1, 2, 3. 0, 1. 1 a third. 1 a 9. So there's our parent, or basic function if you want to call it that. That's y equals 1 over 3 to the x. Now we'll do our transform function. So 4, negative 5, 1, 2, 3, 4, 1, 2, 3, 4, 5. 5, 1, 1, 2, 3, 4, 5, 1. 6, 3, 1, 2, 3, 4, 5, 6. Oh, yeah. 7, 3.7. And 8, 3.9. So that is so they say label the asymptote. Let's do that. We'll draw that in and we'll label our asymptote. So remember, an asymptote is a line the graph gets closer and closer to but never touches. So that's y equals 4. And they say state the domain and range. Well, the domain is x can be anything. And our range is limited by our asymptote. Well, there I go with the equal sign there. It's less than 4, right? We have to make sure it doesn't touch 4. Y is less than 4. Good. Can I elaborate on anything? Explain anything? You guys do the rest of the graphs, get lots of practice, and you also have your homework, which you know is right there. Yes, Michael. Okay, when x is negative 1, we plugged it in, it becomes 5. When y is 3, negative 3 plus 4 is 1. You're plugging in that 3 there. Where negative 3 plus 4 is 1. Any other questions? Yes.
Use the bathroom.
Okay, are we good?